Hi, everybody. I'm Mark Pfeffer, the managing editor of Dice News, and we're here today on this Google Hangout to talk about the Internet of Things. And joining us is Rob Reilly, who's the community director, or I'm sorry, the guide to our Dice News talent community on Linux. And joining him is Bill Weinberg, who's a principal analyst at Linux Pundit and the senior research director at Black Duck Consulting. Gentlemen, thanks for joining us.
Thank you.
Thank you, Mark.
Thanks. Rob, I'm going to start with you. The question really is the Internet of Things. Let's talk about it. What is it, and then why should people care about it?
Right now, there's a lot of press and so on activity around the Internet of Things, which is taking physical computing and hooking it up to the Internet. And why people should care is because I personally think that it will be affecting an awful lot of businesses and tech trends in the future. You'll have you may have your right now you even have your some toothbrushes that are hooked up to the Internet. I just saw a story last week on that, and there's an awful lot of areas in medical, manufacturing, IT that are going to use this technology, I think, in the coming years.
Now, let me just zero in on something. It sounds like it could be a great example of what you're talking about here is a toothbrush wired to the Internet. Why would anybody want that?
Well, right now the business model for all of this is very immature. So it's a really good question, and I looked at it and I said, well, I don't really know why somebody would want this other than maybe to collect data on your child and their habits of brushing, or I don't know where it's going to go. It could. There's a lot of different ways it could go.
There's a lot of novelty stories coming out as people are trying to wrap their minds around what the Internet of Things really involves. For me, it's a stage in evolution that accompanies a redefinition of intelligent systems or embedded systems, intelligent devices. In the old days, we look back and talk about the classic toaster devices where you build an appliance, you build an instrument, you build a weapon system, any of these things that were designed to do one thing. They were pretty much standalone. There was a straightforward user interface or no user interface, with a lot of headless devices, and there was no connectivity. Starting with the introduction, I'm going to say a decade ago to a decade and a half ago, when you began getting desktop and enterprise class operating systems on intelligent devices, everything had the potential to become connected. So the fact is, the real operating systems, as opposed to some of the smaller embedded executives that you would find, all came with networking stacks. It was one of the big reasons that Linux was adopted for embedded systems design in general, starting in around 2000, really. And once you get these devices on a net or on the Internet, you have a whole new paradigm of interacting with them. You're no longer constrained to a local user interface. You can be using a web interface remotely or locally. The functionality of the device changes from being a monofunction provision of activity device to a service delivery vehicle, going to the device and coming from the device. And that paradigm can extend certainly down to smaller, less sophisticated devices, where toothbrushes really is just sort of an idiosyncratic example. You're more likely to be seeing things like sensors, light bulbs for energy control, smaller sensors used with medical devices. And you have to look at the Internet of Things not as point devices connected to something, but as a hierarchy of nodes. So you have nodes running recognizable operating systems, doing fairly sophisticated applications that are taking input or aggregating input from little smaller networks of devices that really only do one thing. They might be a sensor, and they're passing the data up to this gateway or aggregator, and typically that gateway is passing data up to an application running in the cloud and back and forth. So its Internet of Things is not flat. It has a lot of structure to it, and each of the nodes has a different set of software requirements.
So how complex is this going to get? I mean, not in terms of just the simple devices and what each device is sending to, each of its targets, but this sounds like it's going to be an awful lot of infrastructure that's required to make this all happen.
Well, the infrastructure is there to some degree. It really depends on how standardized you want to be. I mean, if you have a device that can directly or indirectly get to a TCP/IP stub that's connected to the internet, usually through a local network, then you're up and running. Then it becomes a question of what are the other endpoints you're communicating with. So if you control the application end to end, you're not going to worry too much about standardization. You're typically going to pick up the very chirpy devices that are doing things like telling you the state of the temperature in a room or a patient's heartbeat or some other sensory activity. That data will be filtered or compressed or in some cases streamed directly through some other kind of aggregation device, because the kinds of devices I'm talking about, the terminal nodes, are typically small, low cost. They're not running TCP/IP. They're doing things like Zigbee or Z-Wave, and they're operating in a mesh network. And then some portion of the mesh network acts as a bridge off to a TCP/IP network, and then you're off to the races.
Well, let me ask you both about this. In terms of building these kind of applications, what kind of skills are people going to need? Is Linux going to be a real driver of this?
Linux is a given. I mean, it's sort of the least common denominator for building both the gateway devices and for building the applications in the cloud. It's more like there's a certain amount of specialty knowledge. I was advising a company in the medical field last year, and their challenges, and there's some challenges in smart energy, is deciding what your terminal devices are going to speak, how they're going to interact with each other, how polyglot do you need them to be? Are you in a position in a marketplace to control the definition of all the terminal nodes so you can set your own standards and use your own versions of protocols sprinkled with secret sauce? Or do you have to interoperate among devices from multiple manufacturers and use more standardized protocols to create a leveling effect, in which case you need to have knowledge of protocols, you need to be able to work with other manufacturers. And the thing that we found, especially in the smart energy application I was working on, is that there's a lot of knowledge about how to build terminal nodes, like the semiconductor companies that want to sell the chipsets for devices powered on Zigbee, for example. They'll give you almost a whole design off the shelf because they want to move silicon. But finding engineers who understand how to set up and optimize the mesh network, now that's really difficult.
Rob, what's your thought?
Well, I'd like to add that I think there's going to be an awful lot of opportunity in this particular area. The typical company, if you're going to build an application on some little node or some little device and connect it up through the network to, say, an Android user interface, your little company will have to have some form of expertise in being able to develop the device, develop your sensors that are connected to the device. You'll have to have some knowledge of networking. You'll have to have some knowledge of radio technology, as in Bill mentioned, maybe Zigbee or Wi-Fi or something along that line. And then you'll have to have engineers and people that can put this together, as well as being able to develop things on the Android side or iPhone side or the mobile side to talk to it and have the two things interact. So I'm thinking there's going to be an awful lot of opportunity.
I think there's going to be a lot of call for architects, because one of the things that Rob highlighted is you might be talking about Internet of Things applications where there's a user interface on an iPhone, where there are other devices that are headless devices in a mesh network, and you need an architect to decide, well, is the network of interest primarily on premises, so you're talking directly to those devices, or is the actual infrastructure up through the cloud and back, or both? And you need someone who can architect that to get the maximum efficiency and the maximum return on investment.
Well, where do you think see the most promising areas are in the short term? I guess another way to ask the question is in the next 2, 3, 4 years, where are the sectors you see leading this whole effort?
I think the medical industry and energy and mobile, of course. Some of the novelty things like Bill talked about earlier. There, with the way you can get startups going now, seems to be an awful lot of interest in that area as well.
There's some differentiation in the market as well. I wouldn't consider mobile to be a target so much as a means to an end, but you have to consider that mobile technology is a very important factor in the Internet of Things, especially right now in Europe. If you go and do a literature search on the Internet of Things, you'll find a lot of mention of 3G telephony. The idea being that if you have nodes that are remote, we've been talking about something on site where there are 3 or 4 devices interacting, or maybe a whole house full of electrical sockets and sensors and things like that. But if you're talking about applications in weather or farming or remote, very remote sensory type things, so putting a seismograph on a mountainside, the idea there is that you don't have access to a network. There's not a mesh running down the hillside of any kind. And so the devices you're putting in place have 3G modems on them, and at some interval they call home. And they may be doing it very frequently, they may be doing it very infrequently. But to support that, what you've seen is a big drop in 3G baseband chipsets for embedding in these devices. And so certainly another skill set, especially in Europe, is for designing in 3G and understanding the constraints of using 3G telephony for data transmission.
Okay. There's been a lot of talk lately about wearable devices, and I'm kind of wondering where this fits in. I think of the bracelets that people can wear to monitor their exercise and their heartbeat and their respiration and all of that sort of thing. Do you think those things have a place that we could call them part of the Internet of Things?
I think as far as the medical goes, that right now we're just getting into these novelty type of things with the bracelets and so on. I think we haven't really hit a miniaturization as far as I thought we would get. Google Glass is a good example, but don't forget that has to interact with a smartphone in order to have connectivity out to everything. So gateways and getting the data to and from the wearable device through a gateway locally over Wi-Fi or XP or whatever, that's going to take a little bit of time to get straightened out, but I think it will. And we may see eventually the low-power Wi-Fi coming into the scene where you have that embedded in a device as well.
Yeah, the wearable computing trend is less, it fits the strict definition of Internet of Things, but my view at any rate is that Internet of Things is an end-to-end operation, and most wearable computing right now is just an extension of mobile telephony. So you have a cell phone, a piece of it will display on your wrist, you might have an eyepiece, and so you're getting information over the internet and displaying it in front of your eyeball instead of on a glass screen in your hand or on a tablet. And it'll come down to whether it really participates in the Internet of Things as a bidirectional device. And some of that goes back to whether you want it to. Is it the right application? There's all across the Internet of Things, there's privacy and security concerns. We tend to look at the upside that my car will call in when it needs, its parts replaced, and the dealer will know about it, but so might my insurance company, and so might the police if I'm speeding and things like that. So each of the applications has its, potentials for good and less good.
What do you think, when we hear about the Internet of Things right now, we tend to hear all of the excitement and all of the potential. Bill, what do you think is the most overblown thing that we're hearing?
I tend to think of it being this Jetsonian vision for the future, and any given single application is being hyped by its manufacturer. So you get novelty devices, you get the hype for wearable computing. It's in many regards the Internet of Things is an architecture, as a vision for infrastructure and how to build applications, and it's not something that's fit for every application right now. It is the marriage of embedded systems and cloud computing and a few points between. So in some regards, it's not particularly novel, and in other regards, once you get ubiquitousness of these devices, there's all sorts of wonderful things you can do going through the world. It's just like anything, it's very new. People would like to see it move forward. I mean, I was very impressed. 2 days ago, I went to San Jose Airport, and I was picking up my wife and daughters coming back from Brazil, and on the bridge across the road at the San Jose Airport was a big sign from Wind River, who's a major player in embedded systems, now a division of Intel, and it was a billboard inside the airport hiring engineers for the Internet of Things. And I was very pleased, and I thought of this call we're having right now, and it'd be a good point to tell. But I know what Wind River does, and I know what these companies do, and in reality, from the point of view of most people in intelligent devices and embedded systems, it's just an extension of existing paradigms.
Okay. Rob, how about you? What do you see as being overhyped?
Right now, to me, the ubiquitous part of it is a little tough to get around, because what I found is working with the hardware. Bill talks about the end-to-end paradigm. When I look at hardware, one of the stumbling blocks that I've seen in industry for this is getting power to power these devices. That's been a major thing that's held everything up for the last couple of years, in my opinion. The same goes for connectivity, and the power and the connectivity go hand in hand, because a little Wi-Fi chip is going to consume a certain amount of power, and how are you going to keep that going if it's sitting out in your yard on a little box on a stake? Maybe you're controlling a sprinkler head out there. How do you get power out there to control that device? Do you use solar? Do you use batteries? How do you charge it? And then the connectivity back, as far as going from the street to your house. That's short range, but you still need the power, and you still need the wireless connectivity. And I think everybody talks about the Internet of Things, and these are going to be everywhere. Well, we still have some problems with the power and the connectivity. But those will be solved. I'm sure they will. The stuff is being miniaturized and improved constantly, and I don't think it's too far off.
There's a couple approaches to the power problem. I was thinking about it yesterday because I'm expanding the security system that I want to have in my house, and I was thinking about camera placement and how I would power IP cameras, which are not, they're not too power hungry, but they're not free either. And the different approaches to power, certain devices are going to become throwaway devices. You'll buy a device with a battery that'll last a year, and then you throw it away and start over. Certain small devices that are fielded are completely power free, in that at the very thin end of the Internet of Things, we're talking about devices like RFID. There is no power in the device. You pulse the device, either going through a portal or with another device, and you're charging it up by pulsing it. It transmits its data back, and it waits until the next pulse. This is how RFID works. And RFID is definitely part of the Internet of Things. It may seem trivial, but smart labels and slugs that are used are, they're already ubiquitous because of the way we do manufacturing. And so that part of it is more a matter of having the right infrastructure to power and get the data back. And then there's some very novel ideas. There were two I read about recently. One's been around for a while, which is harvesting energy from other kinds of activity. So harvesting energy from a road top when cars drive over it, harvesting small amounts of energy from the wind. If put something in your yard like wind chimes, and you're harvesting energy just off of that. And then there's a rather novel space, again, which I'll put in the marginal category, is using your body to generate power right then and there through motion or thermocoupling. They all have interesting potential. It's which will be cost effective is the big question.
Bill, do you have any closing thoughts?
Well, I really like the Internet of Things as a marketer almost more than as a technology person. I think that we tend to ignore the intelligent devices that are around us, which is a good thing, but it also means that we don't value what they do. The Internet of Things is, because it's an interesting meme, it's a concept people are getting into, it's helping non-technical people and technical people alike reevaluate the technology in their lives, how they interact with it, and what value it's likely to bring them. So for me, it's exciting because it's getting more people to realize the impact technology has on their lives and the potential for all purposes. For job seekers, it means there's going to be more kinds of devices, more software being written, more potential, more reason to be reasonably technically savvy in one of several technologies that Rob and I have both discussed.
Rob, how about you? Closing thought?
Yeah, I agree with Bill. I think there's going to be just a wide open arena of opportunity for all kinds of people with all kinds of skill sets. I think there's going to be a lot of cross-pollination between the hardware people and the software people and the network people. A lot of opportunity there, and I think one of the skills that people will really need is to be able to have a bit of openness as far as relating to those other areas that you may not be an expert in. And as far as the hardware goes, I'm looking at an awful lot of development going on, the startup world, the do-it-yourself. I like to call it commercial DIY. Those people have the little hacker spaces, and they're building all kinds of interesting little gadgets and electronics and mechanical things that tie in with the Internet of Things. Just looking on Google and across the Internet, there's just tons of things you can find to learn about it and how to do all this. So I think it's really a good thing, and to me it's very exciting, and I'm looking forward to the future.
Well, it's a fascinating topic for sure, and it's going to be fun to sort of watch this expand over the next few years. Bill Weinberg, Rob Reilly, I want to thank you both very much for joining us this afternoon. And for everybody else, thank you for watching. I'm Mark Pfeffer, the managing editor of Dice News, and we'll see you on our next Hangout. Bye-bye.